Hello children, let us see the derivation of projectile motion today. Projectile is basically when an object is thrown obliquely from the surface of the earth, making an angle other than 90 degree, we call it a projectile motion. Now we have been given only two things. One is the initial velocity u, and the other one is the angle with which the projectile is projected with respect to the horizontal u and theta. So the path will be somewhat like this. It will be a parabolic path that will be concave downwards. We will see, we will derive the equation of path of the projectile also. So first we will derive what is the time of flight of the projectile. So let us split the motion into x-axis and y-axis. We have along x-axis these components. Ax, we all know that along the horizontal in free fall there is no acceleration. So Ax is 0 meter per second square. Then we have Ux, x component of the initial velocity. This is equal to u cos theta. Then we have x. X will be equal to uxt plus half ax t square. As we see that ax is 0, so we simply have x is equal to u cos theta into t. U cos theta into t. Now let us write the equations along y-axis. Along y-axis we have ay is equal to, because we are taking the vertically upward direction as positive, and in free fall acceleration due to gravity always acts in the downward direction, so we will be taking it as minus g. Then uy is equal to u sine theta. Next equation, y is equal to uy t plus half ay t square. So we have y is equal to u sine theta t minus half gt square. Let us take this equation as equation 1, this one as equation 2. Now this is point O, this is point A. We can see that at points O and A, the y component of the displacement is 0. So from equation 2, first we are going to derive the time of flight. Time of flight. From equation 2, y component, putting y is equal to 0, we get u sine theta t minus half gt square. We solve this and get t u sine theta minus half gt is equal to 0. From this we will be getting t is equal to 0 or t is equal to 2u sine theta by g. Now this t is equal to 0 corresponds to the point O, and t is equal to 2u sine theta by g corresponds to the point A. So the time of flight t is 2u sine theta by G. Now second derivation is for the range. What is the horizontal range? Range of the projectile. Range means the horizontal distance between O and A. For this we will be using equation 1. So we write R is basically X, and we have the formula U cos theta into T. In place of T we will be putting 2U sin theta by G. So R is equal to U cos theta into T is 2U sin theta by G. If you solve this, you will get R is equal to U square sine 2 theta over G, where we have used the trigonometric relation sine 2 theta is equal to 2 sine theta cos theta. Now coming to the next derivation that we have, that is for the vertical height or maximum height attained by the projectile. Maximum height. What is the maximum height that the projectile attains during its flight? That this is point B. For this, let us find out the vertical component of the velocity at the point B. We have the equation Vy is equal to Uy plus Ayt. We know that at the highest point of its path, the vertical component of its velocity becomes 0, and Uy is, we know it is U sine theta, and Ay is minus G, so minus Gt. So we get T is equal to U sine theta over G. Now, if we put the value of T in equation 2, we get the maximum height attained. So we have H max is equal to U sine theta T minus half Gt square is equal to U sine theta T is again U sine theta by G minus half G. T is U sine theta by G whole square. So on solving this, we get U square sine square theta by G minus half of U square sine square theta by G. See, we see that this is, if you say U square sine square theta by G is X, then we have X minus half of X. So this will give you half of X. So the result is U square sine square theta by 2G. This is the maximum height attained by the projectile. There is one more derivation for this, that is for the path of the projectile. How do we conclude that the path of the projectile is parabolic and it is concave downwards? So for this, we find the value of T from equation 1. From equation 1, you can write T is equal to X by U cos theta. Now we plug in the value of T in equation 2. So we have Y is equal to U sine theta T minus half Gt square. When we plug in the values, Y is equal to U sine theta and T is X by U cos theta minus half G. T square is X square by U square cos square theta. So we get Y is equal to sine, U gets cancelled out here. Sine theta by cos theta is tan theta. So we have X tan theta minus g by 2 u square cos square theta and x square. So this is the path of the projectile, equation of the path of the projectile. And as we see that the term minus x square is negative, so we conclude that this is the equation of a parabola which concaves downwards. Now, to illustrate the use of the core formula that we discussed right now, let us see a simple question. An object is thrown at 20 meter per second at an angle of 45 degree with the horizontal. Find the time of flight, horizontal range, maximum height, and the object. Find the height of the object at a horizontal distance of 10 meter from the point of. So let us do part A. We have been given the data u is equal to 20 meter per second and theta is equal to 45 degree. So time of flight t is given by 2u sin theta by g. This will be 2 u is 20 sin theta is sin 45 degree by g is 10. So this is 10 2 2 is a 4 by root 2, or you can say this is 4 root 2 by 2 or 2 root 2 seconds. This is the time of flight. Part B. What is the horizontal range? For horizontal range, we have the formula range is equal to u square sine 2 theta over g. So we have u square is equal to 20 whole square sine 2 theta is, as theta is 45 degrees, sine 2 theta is sine 90 degree over g is 10. So this will give us 400, sine 90 is 1 over 10. So this is 40 meter. This is the range. Part C, maximum height. For maximum height, we have the formula h is equal to u square sine square theta by 2g. So plugging in the values, u square is 20 square, sine square theta is 45 degree by 2 into 10. So this 120 cancels 120, we are left with 20 into sine square 45 will be 1 by 2. So this will be 10 meter. Now to find out the height at a distance x, we have the formula y is equal to x tan theta. This is the equation of path of the projectile. X tan theta minus gx square by 2 u square cos square theta. So we have y is equal to x tan theta. X is how much? X is, they have given 10 meter. 10 tan theta is 45 degree minus g is 10. X is again 10 whole square. Then 2u square, that is 2 times u is 20 whole square, and cos square theta will be equal to cos square 45 degree. So let us solve this. Y is equal to tan 45 degree is 1 minus 10 into 10 square, it will be equal to 1000 by 2 into 400, it will be 800, and cos square 45 degree will be equal to 1 by 2, so 2 goes to the numerator. So this is 10 minus 2000 by 800. We get 20 by 8, that is 2.5. So we have 10 minus 2.5, so 7.5 meter. It means that the projectile will be at a height of 7.5 meter at a distance 10 meter from the point of projection.